All right, welcome back. In this lesson, we are going to solve logarithms. So this is using equations to solve for an unknown variable x, and we are going to be utilizing logs and natural logs in here. So for this lesson, I have my lesson, I have my log rules paper. If you guys don't have it printed out, that's fine, as long as you have it in your notes. And I have a notepad because I'm going to do some examples, which would be your notebooks. Make sure you have your notebook. And I have a calculator, just in case. So in solving logs, what we're going to be doing is we're going to be literally solving for a variable in an equation that has a logarithm, a natural log, or that will need to utilize one of those in order to solve. So just a reminder of what a logarithm is, the basic log rule. This is super important that you have it in your notes. So my notes, solving logs, and I'm going to put this basic log rule, log base b of x equals a, and then that double-sided arrow means if and only if. This means that it can go either way. So this is the definition of log. It means what exponent does b need, what exponent does b need in order to equal x? What exponent does b need in order to equal x? So the way that I remember this is I think under to the over equals. Under meaning the base to the over equals. That's the little idiom that I use, or whatever you want to call it. Under to the over equals. Under to the over equals. Under to the over equals. And that's how you can remember how to move back and forth between those two items. All right, so now let's go down and let's do some of these examples. So got my log rules here. Also, I want us to remember remind ourselves if there is no base for the log. So if you have a log of x and there's no base, what is that base? It's a 10, okay? If there's no base written, it's a 10. If there's no base written for the natural log, so see how there's no base there? What is that base? It's e. Good. So if there's no base written, it's e. On this one, if there's no base written, it's a 10. All right, so let's get back to this example, and let's do this first one. Solve means to isolate the variable given. You can only solve if there's an equal sign, which in this example there is. So I'm going to give you 1 second to, actually I'll leave that there. I'm going to give you 1 second to write this down or pause it to write it down. So it says solve log base 4 of x plus log base 4 of 5 equals log base 4 of 12. So what are we solving for here? We're solving for the unknown variable, which in this case is x. So first thing first that we need to do is we need to combine anything if we can. And that's why we did the previous lesson first, condensing logs, because we noticed that we can condense this side of the logarithm. Okay, we can condense that together because they have the same base. So let's go ahead and condense that. That's going to give us log base 4. We have x plus log base 4 of 5, which means that we're going to be using this addition rule to condense. So we're going to multiply the inputs, and the inputs are x times 5. I'm just going to put 5x, and I hope that's okay with you guys. Log base 4 of 12. So I've simplified the left side by condensing it. And you're probably wondering, well, why did I do that? I did that because in order to use these rules down here, like these ones, you can only have one log on one side of the equal sign. And before we had 2 logs on that side, and that wasn't gonna fly. So we had to combine them in order to solve. So now I look at this and I notice that my x is stuck. Where is my x stuck? My x is stuck in an input of a log. The x is stuck on an input of the log. With our x value stuck in an input, we look at our log rules and we say, okay, which of these rules gets our input out? Which of our rules makes our input free? And if I look, this one right here is a good way to get my input out from being stuck in the input, and it gets it out by itself. So this tells me if I have log base b of x, and I take that same value that the base is and raise the log from it, then it can cancel, leaving the input. But here's the caveat. Algebra rules still apply. So what you do to one side, you must do to the other. So let's try it. What is our base here? Well, our base is 4, right? So that tells me if I make this the exponent of 4. So now it's 4 to the power of log base 4 of 5x. But what I do to one side, I have to do to the other. 4 to the power of log base 4 of 12. The good thing here is since the bases on both sides are 4, all of it will cancel out, leaving only 5x equals 12. From here, now we notice all we have left with is 5x equals 12. This is something we know how to solve. This is a basic one-step algebra problem. 5 times x equals 12. How do I get x by itself? I divide by what's multiplying by the x. So I divide by 5. What you do to one side, you do to the other. That gives me x equals 12 over 5. And if the answer is in decimal form, you can just do 12 divided by 5 on your calculator, and that gives you x equals 2.4. All right, so anytime you're solving a log or solving a logarithm or solving an equation, you want to get x equals something. You want to get a numeric value as your answer. If you don't have a numeric value, then you probably did something wrong. So you want to look back at it. All right, let's go ahead and do another example, because with solving logs, these are kind of problems that you just really need to practice. You just need to do a bunch of practice. So let's do this next one. I want you to take the time to write this down in your notebook. Solve natural log of x squared equals 6. Solve natural log of x squared equals 6. First things first, let's remind ourselves, if there's no base there, what is the base of natural log? The base is e. So I can go ahead and write an e in my base to remind me that that base is e. Okay, so now we're going to use the log rules again. I look at my log rules. I have it right here next to me. You have it in your notebook. And I say, where is my x stuck? Well, right now my x is stuck once again in an input. Well, the only rule that tells me how to get an x out of the input is that exact same rule that we just used. So now we're doing natural log. What we're going to do is we're going to raise both sides from e. So now this is an exponent of e. What you do to one side, you do to the other. That will cancel, leaving you with x squared equals e to the 6th power. And you're probably like, Meryl, what the crap is an e to the 6th? Well, guess what? On your calculator, there's an e button. It's right there. It's in blue, so you press the blue button to make the blue thing happen. E to the power of 6 gives you some weirdo number, but that's still a number, so we're in business. So now I say, okay, well, x squared equals some big old number, 403.4287935. X is still not isolated. It's being squared. The opposite of square is square root. What you do to one side, you do to the other. Those cancel. X equals the square root of this crap right here. And you get some cool decimal, let's round to one decimal place, 20.1. I got a numeric value to solve my natural log, which means I probably did something right if I got a number. All right, next up, I'm gonna start doing some questions from the quiz, just because, like I said before, the more examples you get under your belt, the more comfortable you'll be solving logs. So go ahead and write this question down in your notebook, and I'm going to write it down in my notebook as well. So solve -6 log base 3 x minus 3 equals -24. All right, so in this problem here, once again, solving means isolate the x. Where is the x? Where's the thing we're trying to isolate? Once again, it's in the input. So I'm going to eventually be using that same rule that we had been using all along. But I notice that my log isn't isolated right now. And in order to utilize that rule, that log has to be isolated. So I first have to get that log by itself. So right now what's happening to the log is it's being multiplied by -6. So I've got to undo that multiplication. So I've got to divide by -6. And what you do to one side, you do to the other. Those are going to cancel, leaving you with log base 3 x minus 3 equals negative divided by a negative is a positive. 24 divided by 6 is 4. Now, if I'm ever moving too fast for you, just pause the video, take notes, or go ahead and rewind and rewatch. All right, now I notice that this log is isolated on that side of the equal sign, which means I can go ahead and use this rule to get the input out of the input to get it isolated. So I notice my base is 3. I'm gonna raise that from the power of 3. What you do to one side, you do to the other. So this is gonna be 3 to the power of 4. So that leaves me with x minus 3 equals 3 to the 4th power. Well, isn't that just 3 times 3 times 3 times 3? Or if you don't want to worry about it, you can just do that crap in your calculator, 3 to the 4th power, and that gives you 81. Now it's a simple algebra problem. You guys totally got this. Add 3 to both sides, and you get x equals 84. So on this question, you would simply write 84. You don't want to put the x equals, you don't really need that. You just type in 84 and then you go next to the next question. All right, I'm going to go ahead and fast forward and try to find a question that is not like one that we have done before or already. Because we've done 3 already where the x is in the input. I want to do one where the x isn't in the input. So let's go ahead and do this one. So go ahead and take a second to write it down in your notes, and I'll write it in my notebook. Solve 3 to the x plus 1 equals 7. All right. Solve 3 to the x plus 1 equals 7. So I notice here that my x value that I'm trying to solve for is in an exponent. Now, before laws of logarithms and before log rules and natural logs, literally like 4 days ago before you even started logs, there was no way to solve for that x value. There was no way that you could actually solve for it unless the bases were the same, which they're not. Okay, but the beauty of logs is now there's this whole realm of x values that we can solve for if they're stuck in exponents. So this x is stuck in an exponent. I have to look at my log rules and say, okay, which log rule shows me an x stuck in an exponent coming down out of the exponent? It's this rule right here, the third log rule. It says if you have the log of something, base something with an input, and the input has an exponent, that exponent can come on down in front of the log. Now you're probably wondering, Meryl, how does that even apply to this? I don't have a log here. Well, guess what? If you follow the rules of algebra, anything is possible as long as what you do to one side, you do to the other. So I can create the log. I can say, you, sir, are now the input of a log. But if I do that, I have to do it to the other side as well. So now this is actually going to be log of 3 to the x plus 1 equals log of 7. Now, notice I didn't put a base there. It's assumed it's 10. Okay, so all I did is I took the log of the left side equal to the log of the right side. Simple, right? So now that I have a log, the input has an exponent, I can simply bring this sucker down in front. So now this is going to be x plus 1 times the log of 3 equals the log of 7. Now we just do basic algebra. We just have kind of bigger pieces, but that's fine. That's totally fine. This is just algebra. My x is right here in this parenthesis thing that's being multiplied by a log of 3. So how do you undo multiplication? Division. I'm going to divide this by log of 3. What you do to one side, you do to the other. Log of 3, bam, bam. Now on the left side, I simply have x plus 1 equals log of 7 over the log of 3. Now I know you're tempted to combine that, thinking that you can use rule number 2, but you cannot. You cannot, because this is not log of 7 over 3. It's log of 7 over log of 3. And notice that doesn't match. Anyway, just don't do it, okay? Don't combine that crap, okay? That's all I'm saying. Now, x is almost isolated. How do I get x by itself? Minus 1. What you do to one side, you do to the other. X equals log of 7 over log of 3 minus 1. And you're probably like, Meryl, you said the answer has to be a number. How is that a number? Guess what? It is a number. It's just a weird wonky one, okay? Sometimes the answer will be written like that, and sometimes it'll be written as a decimal that I'm gonna calculate on my calculator. So if it's looking for the exact answer, that's what it's gonna be. That's the exact answer. You can also find it on your calculator. The log button's right here. If you have a phone, you usually have a log button if you expand your calculator. Log of 7 equals divided by log of 3 equals minus 1 equals. There we go. So this tells me x also equals, let's round to 2 decimal places, 0.77. And that's it. Okay, good luck with your homework, you guys. I know you can do it. If you have any that you're stuck on, go ahead and shoot me a message. Have a great day.